this problem from pair of straight line, and the problem is prove that the straight lines joining the origin to the point of intersection of the straight line x by alpha plus y by beta, this is equal to 2, and the circles are at right angle if alpha square plus beta square, this is equal to gamma square. Okay, we first name this circle as equation number 1 and this straight line as equation number 2. And in this problem, to solve, we use the result, an important result, pair of straight line. This is the homogeneous equation of second degree, that is the pair of straight line passing through the origin, are at right angle if a plus b, this is equal to 0, that is the coefficient of x square plus coefficient of y square, this is equal to 0. We directly use this result. Okay, now if we draw a rough sketch of this circle, this is the circle of radius gamma and center at alpha beta, this is alpha comma beta. Okay, and radius is gamma. We draw the radius gamma, this is gamma, and if we draw the line, this is the line, and let the line is such that x by alpha plus y by beta, this is equal to 2, and let these are two axes, this is x axis and this is y axis. Okay, we first find the line passes through the origin and through the point of intersection of the straight line and the circle. Let it be OA and OB. A and B are the point of intersection of 1 and 2. Now to get the pair of straight line OA and OB, we make homogeneous one with the help of 2. Okay, and before going to making homogeneous, we expand this equation as we write the second degree term first, this is x square plus y square, minus then the first degree, this is 2 into alpha x plus beta y, and then the 0 degree term, that is the term which are constant, this is alpha square plus beta square minus gamma square, this is equal to 0. Right, now to make homogeneous this equation, with the help of this we get here x square plus y square, this is already second degree, minus 2 into this is alpha x plus beta y into, we can write this is into 1, and here we write alpha square plus beta square minus gamma square into 1 square, this is equal to 0. Now put x by 2 alpha plus y by 2 beta in place of 1, because this is the line 2, and getting the homogeneous equation as x square plus y square minus 2 into alpha x plus beta y into this is x by 2 alpha plus y by 2 beta. This is 1 plus this is alpha square plus beta square minus gamma square into x by 2 alpha plus y by 2 beta whole square, this is equal to 0. Okay, this is the homogeneous equation of second degree. Now we have to prove these are at right angle if this. Okay, so we write here the coefficient of x square and coefficient of y square only. Okay, now zero, this implies this is the condition of right angle of two straight line, which are the coefficient of x square is, first we write coefficient of x square, this is 1, and from here we get this is minus 2 into alpha into 1 by alpha into x square, this is 2. Okay, and from here we get this is plus alpha square plus beta square minus gamma square into 1 by 2, sorry, yes, 1 by not 2, this is square, so this is 4 alpha square. This is the coefficient of x square. Okay, and now we write the coefficient of y square. What is the coefficient of y square? This is clearly 1, the first term, and in the second term this is obviously 2 into beta into 1 by 2 beta, 1 beta into 1 by 2 beta. Here also 2 into alpha by 2 alpha. Here we write a wrong term. Okay, now the last term of y square is this. This is plus alpha square plus beta square minus gamma square into 1 by 4 beta square, and this is equal to 0. Now we get, this is also a negative, we get this and this cancel out, this and this cancel out, because this is 2 beta by 2 beta means 1, 2 alpha by 2 alpha means 1. So only 2 terms we get. This is alpha square plus beta square minus gamma square into, this is 1 by 4 alpha square plus 1 by 4 beta square. Okay, this is equal to 0. So we get alpha square plus beta square minus gamma square into alpha square plus beta square. This is equal to 0. Now here alpha square plus beta square not equal to 0, since if alpha square plus beta square this is equal to 0, so alpha this is equal to 0 and beta this is equal to 0. Okay, and then the circle becomes a circle with the center at origin. Okay, so here it is not given that the circle is passes through the center of the circle is at the origin, so we take only alpha square plus beta square minus gamma square. This is equal to 0 for the condition of right angle of two straight line, that is alpha square plus beta square. This is equal to gamma square. This is our required result. Okay, we want to prove this. Right, this is very simple problem but important problem of pair of straight line. Thank you for watching.